So today we're going to talk about radioactivity and decays. First of all, what exactly is radioactivity? Now, radioactivity is the process of spontaneous emissions of alpha, beta, and gamma radiations from the nucleus of an atom. Why does radioactivity occur? What causes a nucleus to become radioactive and start emitting these different radiations? Radioactivity occurs when there is a large difference between the mass number and the atomic number, which means that there is a lot of difference between the number of protons and the number of neutrons. It generally occurs when the number of neutrons is much larger as compared to the number of protons. This causes the nucleus to become unstable, as a result of which, in order to make the number of neutrons and the protons closer to each other, it begins to emit certain radiations and it tries to make the nucleus more stable by doing so. So there are three different types of decays or radiations. You have alpha particles, and if alpha particles are released, then that's called alpha decay. An alpha particle is nothing but a helium nucleus. A helium nucleus is the helium atom minus the two electrons, so it's just two protons, two neutrons, and thus it would have a positive charge of 2 plus. Beta particle is nothing but a stream of fast moving electrons, and therefore it's got the same mass as an electron. And gamma particles, actually, the catch here is that we would think that it's gamma particles, but actually it's not. It's gamma rays. Gamma rays are electromagnetic radiations that move with the speed of light. So it's actually rays that are getting emitted, electromagnetic radiation, not really particles. And the decay is called as gamma decay. So what happens during an alpha decay? Alpha particles are emitted. So you're going to have a helium nucleus being emitted, and you know that on both sides of an equation, any nuclear equation, number of the mass number and the atomic number need to be conserved. So here, if we have 4 and 2, then the new daughter nucleus would obviously be a minus 4 and z minus 2, because then when we add a minus 4 plus 4, we get a, which is on this side, and when we do z minus 2 plus 2, we get z, which is on this side. So parent atom, daughter nucleus, parent nucleus, daughter nucleus, and the alpha particle. Similarly, in beta decay, we have an electron being released, which means that this should ideally be Z plus 1. Atomic number increases by 1, mass number remains the same. And in gamma decay, you have an atom in an excited state getting stabilized. It basically comes to its ground state. Gamma rays are emitted, and there is absolutely no change in the mass number and atomic number. So here you have X and here you have Y, which is different from X. But in this case, because atomic number and mass number are not changing, it's just X, but it doesn't have the star anymore. The star is symbolizing the excited state. Here, it is a ground state. It's no longer an excited state. So that's all about radioactivity and the different types of decays.